Let's take a look at square roots. Now you know the perfect squares. The perfect squares that you know are, of course, 3 times 3 would give us 9. So if I tell you to get the square root of 9, you would know that that would be 3. What I'm saying is, what number times itself is going to equal 9? Look at number 2. If I say I want the square root of 121, I'm asking what number times itself would give me 121? And the answer, of course, is 11. You should really know the perfect squares up through 13 times 13. Let's take a look at example 3. This one is a fraction, and it's a little confusing, but it doesn't have to be. It's really saying the square root of the numerator over the square root of the denominator. Well, you know the square root of 1. 1 times 1 equals 1. What times itself equals 81? Well, that would be 9. So the answer to that is the fraction 1/9. What if, though, they're asking you to get, in example 4, a square that's not perfect? In other words, the square root of 5. Well, you can estimate. You can say it's between two numbers. Think, the next square that would be smaller than 5, perfect square, would be the square root of 4, right? Which we know that is the number 2. And then the next one would be the square root of 9. That's the next bigger one. And we know that is the number 3. So the square root of 5 is going to be between 2 and 3. So somewhere between 2 and 3. You've pretty much narrowed it down. How about the square root of 12 in example 5? Well, smaller square root of 9, which is 3. Larger square root of 16 would be the next one. That's 4. So here we are again. The square root of 12 is going to be between 3 and 4. Now, how do we use square roots? We have one theorem that's very important called the Pythagorean Theorem. The formula for it, you probably remember, is a squared plus b squared equals c squared. It's used to find an unknown side for a right triangle. Now, the triangle has to have one angle in it that is a perfect 90-degree angle. We call that the right angle. And the only thing that's important in the Pythagorean theorem is that you set up C in the right place. C is the longest side of your triangle, the one that's opposite the right angle. So this side has to be C. It really doesn't matter which of the other two is A and which one's B. We're just going to pick 2. Always start by writing down your formula or your theorem, a squared plus b squared equals c squared, and then fill in the numbers you know. In this case, I know A is 12 squared. And I know B, well, that's 5, so it'll be 5 squared, and that's going to equal c squared. Well, let's work the math. 12 times 12, you should know this one, 144, right? Plus 5 times 5, 25, still equals c squared. Let's add those two together. 144 plus 25, that will give me 169. And that's equal to c squared. Now, I know how to solve for c over something, but how do I solve for c squared? What I have to do is take the square root. In other words, what times itself is going to give me c squared? What would be c times c? That's what I want, is c all by itself. Therefore, I have to take the square root of the other side. The square root of 169 is 13. That's the square I told you. You should know your squares all the way up through 13.